Ever wondered what is the secret behind the magic of Kubernetes orchestration? How does it manage to keep everything in sync? Today, we're going to take a closer look at the cogs and gears that drive this powerful system. It's a tale of two key components, etcd in Kubernetes and the Kuber scheduler. Together, they ensure Kubernetes operates like a well-oiled machine, managing, deploying, and scaling your applications seamlessly. Well, the answer lies in two words, etcd and kubescheduler. Intrigued? Keep watching. Let's not beat around the bush. etcd is Kubernetes' brain, storing all its knowledge. Imagine you're in a vast library filled with books from floor to ceiling. Now think of etcd as the diligent librarian, maintaining a meticulous record of every single book in that library. From the oldest history tome to the newest science fiction novel, the librarian knows exactly where each book is and how many copies are available. That's etcd for you. In the Kubernetes universe, etcd plays a crucial role as the ultimate source of truth, storing all the configuration data and state information. Just like our librarian, it keeps track of everything, ensuring that the Kubernetes system knows what's happening at all times. When you use Kubernetes, you're essentially dealing with a multitude of books, be it pods, services, deployments, or secrets. Each of these books has its own unique details and specifications. And just like how a librarian would record important details about each book, its title, author, genre, and location, etcd stores all the vital information about these Kubernetes books. Moreover, etcd doesn't just record this information, it ensures that it is consistently updated and synchronized across the entire Kubernetes cluster. So, if a book is borrowed or returned, the librarian makes sure the record is updated promptly. Similarly, if there's a change in a pod or if a new service is deployed, etcd updates its records accordingly, ensuring that the state of the Kubernetes cluster is always current and accurate. But what makes etcd truly stand out is its fault tolerance. Our librarian, for instance, might fall ill or go on a vacation, but with etcd, there's no such worry. It uses the Raft consensus algorithm, which means even if a part of the system fails, the rest can continue to function seamlessly, ensuring that your Kubernetes cluster remains up and running no matter what. So in a nutshell, etcd is the librarian of Kubernetes, keeping track of all its books. Now that we know who keeps the records, let's meet the one who does the planning, the kubescheduler. Imagine a bustling city with cars buzzing around trying to get to their destinations. Now, think of a traffic controller. Their job is to manage the flow of vehicles on roads, ensuring no accidents occur and everyone reaches their destination safely. Similarly, in the world of Kubernetes, the kubescheduler is our traffic controller. So what exactly does the kubescheduler do? It's responsible for scheduling pods in a cluster to run on nodes. When you create or scale up a deployment, the kubescheduler springs into action. It takes into account the requirements of each pod, the resources available on each node, and any constraints or policies that might be in place. For example, consider a pod that needs a lot of memory. The kubescheduler won't place this pod on a node that's already running memory-intensive pods. It's like our traffic controller not sending a large truck down a narrow alley. Instead, it will find a node with enough available memory to handle the pod's demands. But it's not just about resources. The kubescheduler also considers factors like data locality, hardware/software/policy constraints, affinity and anti-affinity specifications, and even load balancing. It's like our traffic controller considering road conditions, traffic rules, and rush hour timings. And just like a traffic controller, the kubescheduler is constantly monitoring the road conditions. If a node fails or becomes overburdened, the kubescheduler will divert traffic. That is, reschedule the pods to other nodes. In essence, kubescheduler is the traffic controller of Kubernetes, ensuring smooth traffic flow of pods. It's the one making sure that all the vehicles in our Kubernetes city get to where they need to be efficiently and safely. The kubescheduler is a key component of Kubernetes, and understanding its role is crucial to mastering this powerful tool. In essence, Kubescheduler is the traffic controller of Kubernetes, ensuring smooth traffic flow of pods. You might be thinking, how do etcd and Kubescheduler work together? Well, they are a dynamic duo. Now, let's imagine Kubernetes as a bustling city with etcd and Kubescheduler as a power couple managing it all. etcd is like an obsessive-compulsive librarian who keeps track of every single book in the library, which in our case are the nodes and pods. It is responsible for storing all the data about the state of the Kubernetes cluster. It remembers everything from which nodes are part of the cluster to the specifics of each pod to the services that are running. It's like the ultimate diary keeper of our Kubernetes city, jotting down every single detail. Now enter Kubescheduler, the strategic city planner. It is responsible for deciding where new buildings, or in our Kubernetes city, new pods should be placed. It uses the data stored in etcd to make informed decisions. It's like the partner who plans every date night, every vacation, every little event using the meticulously kept records of etcd. So, how do they work together? Well, when a new pod needs to be scheduled, Kubescheduler steps in. It looks at the information stored in etcd, the state of the current nodes, the resource requirements of the new pod, and so on. Then, it makes a decision based on this data about where the new pod should be placed. It's like planning where to put a new park in the city, taking into account the existing buildings and the needs of the citizens. And once the decision is made, it's back to etcd. The new state of the cluster, including the placement of the new pod, is stored in etcd. It's like updating the city's records after a new park has been built. In this way, etcd and Kubescheduler work together, each playing a crucial role in managing our Kubernetes city. They are the power couple of Kubernetes, keeping everything running smoothly. We've covered a lot of ground today, so let's do a quick recap. We started with an intriguing query about the inner workings of Kubernetes. Remember the question that sparked our journey? We wanted to understand the secret behind Kubernetes' efficiency. We then dove into the world of etcd. We discovered that etcd is no ordinary database, but a distributed, reliable key-value store used for critical data of a distributed system. It's the trusted source of truth, storing the configuration details, state information, and metadata for Kubernetes. From there, we ventured into the realm of the Kubescheduler. This intelligent component takes the heavy lifting of assigning workloads to the appropriate nodes. It's like the mastermind behind the scenes, juggling resources and ensuring that every task finds its perfect fit. And then we brought these two powerhouses together. We explored how etcd and the Kubescheduler interact, creating a dynamic duo that makes Kubernetes the powerhouse that it is. etcd provides the data, and the Kubescheduler uses this data to make informed decisions about where to place workloads. So, you see, Kubernetes isn't just magic. It's the result of brilliantly designed components working in harmony. So next time you marvel at the magic of Kubernetes, remember the power couple behind it, etcd and Kubescheduler.